Hello, my name is Beth Dixon, and this is part 3 of a video series on frequency distribution in histograms. Remember that our goals were to, given raw data, construct a frequency distribution, relative frequency distribution, percent frequency distribution in histogram. And in parts 1 and 2, we have done A, B, and C, and we're ready to proceed with histograms. I also hope in this video to cover, given that frequency distribution, to find the lower class limits, the upper class limits, and the class width. And then in the next one, to using raw data, construct the classes when given the lower class limits of the first class and the class width, and a word of caution about the vertical axis on the histograms. Next, we will make a histogram of the data. A histogram is a graphical representation of the data and can also be known as a bar graph. In the upper corner, we have a copy of our classes and our frequency. If you have skipped straight to this video, you will not be familiar with this data, but that's not necessary to listen to just this video. If you have listened to and watched parts 1 and 2, you're already very familiar with the data in the upper corner. Next, we will need a horizontal and vertical axis, which are drawn here. On the horizontal axis, we will put the classes. This does vary by teacher, so please check with your teacher as to the exact way he or she wants it done. I will do it the way Mrs. Borlaug wants it done and has done it since we are using her PowerPoint. Notice the labels of weights in pounds and the tick marks along the horizontal axis. And the classes then are listed as ranges in between the tick marks. On the vertical axis, we will put the frequency. Looking at the frequencies of our table, we will see that our largest number is 12. 12 tick marks is too many for our graph, so I will count by twos. This can vary and doesn't have to be exactly the same student to student, but you want to be at least as high as your largest number in your frequency. It can be greater, but it has to have at least that 12 in our case here. Now we are ready to start our histogram. Each class will be a bar, the height of the frequency and the width of the evenly spaced tick marks on the bottom. The first class has a height of 3. So we draw a rectangle 3 high over to the first tick mark, and that makes our first bar. The next one has a height of 5, then 9, then 12, then 5, then 4, and the last one has a height of 2. Notice how the graph looks. Notice the details. Notice how Mrs. Borlaug wrote in the numbers on the top of the graph for emphasis. This is not always done, but for our purposes it will help clarify what's going on at this stage. Notice that we can look at the shape of the data, how more data is in the center and fewer numbers are at the end, how it has almost a bell shape. which we will talk about later in the course. Actually, we'll talk about it later in this video. This completes the histogram of the students' weights. We now can go on and go to goal number 2 because there's still more to learn about our table. And we will learn how to find the following: the lower class limits, the upper class limits, and the class width. When talking about classes, we need a way to describe them. I have already used terms like Class 1 and Class 2 and so on. This would be Class 1, this would be Class 2, Class 3, Class 4, Class 5, Class 6, and Class 7. So we could say our data has 7 classes. We will also use the term lower class limit when we're talking about classes. The lower class limit is the classes, there goes my phone, so I'm just going to turn the ringer down. The lower class limits are the class's lower numbers. The lower or smaller numbers of each class gives us 118, 127, 136, 145, 154, 163, and 172. Next, we will look at the upper class limits. The upper class limits are the class's upper numbers, the numbers on the right side. These are the class's upper numbers or higher numbers of each class: 126, 135, 144, 153, 162, 171, and 180. Lastly, we need to look at the class width, which is the distance between classes. Notice this is the distance between classes. That means we need to look at 2 classes, not the distance inside one class. Between classes implies and means from one class to the next class. So we find the distance between the first class and the second class by subtracting how far apart the lower class limit of one class is from the lower class limit of the next class. We know that there is a gap, and we talked about that in part 1 of this video series, that there's a 1 pound gap between the classes, but what's the width from lower to lower? And we can do that by subtracting 127 minus 118. That gives us 9. And there is a jump or width of 9. Again, notice we're going from one class to the next. 127 minus 118 gives us 9. We can repeat that process by going from 136 or 127 to 136 and subtracting 136 minus 127, and that distance is 9 as well. Let's subtract 145 minus 136. We get 9. 154 minus 145, we get 9. 163 minus 154, we get 9. 172 minus 163, we get 9. The distance between each class is 9, so the class width is 9. Did we really need to do all of the calculations to get the class width, or could we just do one of them? You only needed to do one of them, and it doesn't matter which of the pairs you choose. Usually, it's easiest to choose either the first two you come to or the last two that you come to for the ease of picking them out, and just compute one of those subtractions. So let's do a quick summary before we wrap this video up of the results of the lower class limits, the numbers to the right, the upper class limits, that was numbers to the left, the upper class limits are the numbers to the right, and the class width, which is the distance between the first lower limit and the second lower limit, and subtracting 127 minus 118. And yes, I know I said that all backwards, but look at the screen to figure out how you're supposed to subtract. Thank you for watching, and I'm going to wrap this up. Please watch the next video where we will do another example, and if you need additional help on figuring out how to do frequency distributions and histograms.